Hello everyone, welcome to AI Anytime channel. Today we are going to work on a very interesting project. Yes, we are going to develop an AI application that aims to detect plagiarism in language model responses. Now, I will take you through the process of building a Streamlit app inspired by other apps like GPTZero and Turnitin. You might be aware that there have been plagiarism tool already available that claim that they detect AI plagiarism, whether those contents are being generated by a generative AI model or not. That's what we are going to do in this video, guys. We will go and try to build simple application in Streamlit based on some NLP techniques and metrics. Okay, we are going to look at Perplexity and Burstiness to create some kind of logics which will help you derive some insight if the contents are being generated by AI or not. Okay, so let's jump in. So if I talk about a little bit on how there have been other tools. If you see currently GPT-Zero, I am on their website. It says the world first AI detector with over 1 million users. Okay, they now have the paid version. Earlier when they started, they had a Streamlit application. I do believe that they still have that Streamlit application hosted somewhere, that you can try it out. You can see that they have AI. If you click on that, they have GPT-Zero Classic. They also provide now API integration, so you can use their API. If you want to integrate in your existing project, okay, for detecting AI plagiarism. Okay, and then we also have Turnitin, which is very famous in academia, by the way. So I was going through some Reddit post where I found some people complaining, or I'll not say complain, being little concerned that their papers or their assignments have been flagged as AI generated, even they were not AI generated. And that's the professors mainly in academia, they're using Turnitin, for example. So these are the tools which are paid. They have their API, they have their Chrome extension. How can we build a simple tool like this? What are the techniques that we can look at it? When we are talking about large language models, what are some of the fundamentals, technique or fundamentals knowledge that we should have when we are trying to interact with this kind of tools, basically. So if you want to build a similar tool, what is the approach to build that? That's what we are going to look in this video, guys. So if you see, I'm currently on my cache here, and I will explain couple of very fundamental techniques. And I do have a video on the same topic previously when I was comparing open source LLMs with closed source LLMs, for example, Alpaca and Llama versus GPT-3 or 4 at that point of time. So you can also find that video link in the description. But in this, what I'm going to do, I'm going to explain a few things. The first thing will be Perplexity, of course. So we are going to look at Perplexity and Burstiness. How we can use these techniques, okay, basically the metrics, to come up with a logic that will help you derive the insights, right? It will give you some cues if that are being generated by AI or not. So we are going to look at these two metrics. There are more that you can evaluate as well. So if I talk about language model, what do we mean by Perplexity? So let's start with Perplexity first. Let me just make this little full screen here. So now what do we mean by Perplexity, guys? So it measures basically, so it measures how well a language model predicts a given sequence of words. This is the definition, a very high level definition of Perplexity. So now a lower Perplexity, so suppose if you have a very low Perplexity, so a lower Perplexity is nothing but indicates that the language model is more confident. Okay, and that's what you see with the language model. If you go and ask ChatGPT to give you a response with high randomness and coherent, it might not give you. Okay, so a lower Perplexity indicates that a language model is more confident. A language model is more confident. more confident, in and accurate in predicting the next word. Okay, more confident in predicting the next word. Let me just write that as well. Predicting the next word. And this is going to be a little long video, guys, because I'm going to cover everything from scratch, or not everything but most of the thing. So how do we now basically define perplexity mathematically with a mathematical formula which is very fundamental and intuitive? Let's call perplexity as p here in this case. So it is defined as nothing but 2 to the power h. If you talk about the h here, which is nothing but called as entropy, so it represents the entropy. So I'm just calling it entropy here, entropy of the sequence basically. So we have the sequence, so it's entropy of the sequence, which is calculated, and I'll show that how do we calculate. So which is calculated as the average negative of log probability of each word. So let's take an example to understand this, in layman terms now. So in each word, basically in the sequence. So the formula, as you see, is p equals 2 to the power h. Now let's understand, and just to give you some example here, 2 to the power h. Now this 2 to the power h that you see is used to basically convert, because we need a value right there, right? We cannot just go ahead with the same value. We need a perplexity value that will help end user interpret, right, with ease. Okay, that's what we are going to do here. So 2 to the power h is used to convert entropy to a perplexity value. Okay, now let's understand this with a sentence here. So suppose if this is my sentence, okay, I love to eat ice cream, for example. I love to eat ice cream, which I really don't in my real life, but I'm just writing I love to eat ice cream. Now this is the sentence, for example. How do we explain perplexity, okay, with this sentence? And with the same technique, we are going to write the code. When we are building this Streamlit application, we'll write the function, we'll write the basic functions with the help of natural language processing library like NLTK and what other model. So it depends also on what kind of language model that we are taking into consideration. In this video we are going to look at GPT-2, which is an open source model available on Hugging Face, and that's the model we'll use as our baseline. Okay, so let's now see. So we have I love to eat ice cream. How do we kind of go ahead and explain this? So for explaining this, I'll select a very simple language model. So let's suppose, for example, we have a pre-trained model. Let me just write it over here again. So we have a pre-trained language model, because we need a base model, or we need some kind of language model to explain perplexity when it's related to a sentence or a text or a paragraph, whatever it is, right? So pre-trained language model, and in this case I'm going to use a simple bigram model which will help me explain easily in this video. So bigram model, I'm taking this a bigram sample. I'll explain what bigram basically means. Now we have this I love to eat ice cream. How do we calculate now? So let's follow step by step. The first thing that we always do when we have this text data, basically we pre-process it, right? That's what we do. So let me just write it here. So I'm going to say, okay, pre-process, and pre-process is nothing, we are going to tokenize this. So let me just write. So pre-process, which is tokenize. In this case, how do we tokenize this sentence? This is how we are going to define this. For example, let's do that in a list here. So I love to eat ice, and something like here, like the last one, the cream, right? I love to eat ice cream. Okay, this is basically the pre-processing step, the tokenizing the sentence. Okay, the first step. Now what do we do? We calculate. So let me just write. So we calculate Okay, let me just write it a little bigger so you can see. Calculate the negative log. So calculate the negative log probability. Calculating the negative log probability for each sentence. So for each sentence we have to calculate the negative log. Now why do we are taking the negative log is because it will help us convert probabilities into a logarithmic scale, so we can calculate that, the formula that we saw, 2 to the power h, right? So now let me just show you what I'm talking about. So now for example, how do we define it for a bigram model? So please see this, we have a bigram model, right? So how do we explain this? So pi, which is the first word, the first token, basically the first word, and pi, so this is nothing but the probability of I according to the language model. And we do explain it same for other words. So what was my other word? I love to eat ice cream. So the next is love. Now how do we write it? So we write like this because we have considered a bigram model, right? So love and what is the previous word that we have in the sentence, which is I. Now if model has to predict that, how do we write it here? So this goes like this. So probability, so this goes like this: probability of love given I. So if you are giving I as the first word, if you have I, what should be the next word? If model says, okay, if love is the next word, then that's how we write it: probability of love given I, and then same goes according to the language model. So that remains same. Now you can write the same for the other words as well. So I love to, so that goes to, and then we have love. Now you can write it same for this one as well. Here just to make some changes, here will be to, and here it will be love, and that remains same. So now I love to eat ice cream, so that goes eat and the previous word. So I hope you understand this one. So let's come to the last one, which is cream and cream ice. So the last one remains I, and this is how we do. Now how do we basically donate this? Okay, basically, right? So p cream ice. Now if we have to define this as a logarithmic of p and I, so log pi, and we have to take the negative log. So this is how we define. So negative log p of I, and then we have log p of, again, the first word that followed by I was love, and then the previous one was I, and that's how we again take the log of it. So log p and then love and this word I, and this is how we basically do it for all the words. So let me just go to the last one, which is nothing but the log p, and which says cream, and the previous one is ice, and this is how we get this. So log p cream and then ice. Okay, now how do we calculate? So let me just write the third step, which is the final step, calculating the entropy. So calculating the entropy now, because we have the negative log of it. So calculating the entropy. So how many? If you come here, you'll see we have 6 words. Okay, let me just make it a little shorter. So maybe I'll not write the entire formula here. So what I can do, I'll just use summation and make this little short. So calculate the entropy. So you have your 6 words. So the formula goes like this: 1 upon 6, 1 by 6, and applying this summation of log p, and the word I, the I word, it's not a minus, it's just word underscore I. And if I just give let me just, if you can write it over here, word, and this becomes I minus 1, because it takes the previous word. So if you see it over here, the pi and the love I, right? So this is how we define this: 1 upon 6, because we have 6 words here. So, and then we are multiplying the summation of logarithmic of word I and word I minus 1. So this is basically the formula of perplexity, guys. Okay, in this case, now we define the perplexity once by this formula, and we are going to write a function for this. We are going to write a calculate perplexity function in Python when we are building this Streamlit application. If you are not interested in the mathematical part of it, please forward this video and you can start it from the Streamlit application when we are building it. Right now, if I move to burstiness, for example, which is again a very interesting topic, and burstiness is more intuitive. So if I talk about burstiness now, so it's nothing but it measures the deviation. Okay, just let me write the definition here. So it measures the deviation of word occurrences from the average frequency in a text. So we'll take an example for this as well. Average frequency in a text. So it helps us basically to understand the distribution of word occurrences and identify any significant deviation. Let's take a simple example so I can help you understand. So if, for example, if let's take something like the cat sat on the mat, something like this, which it sounds very similar, all the words. The cat sat on the mat, and the next one is in the same line. The mat was soft. We need some repetitive word as well. You can see mat is a repetitive word in this case. Now suppose if this is your text, the cat sat on the mat and the mat was soft. Again, the first step will be the tokenize that we saw in perplexity. Tokenize. So how do we tokenize it? I'm just going to write for few word here, guys. You can rest of it you can follow. So last one was soft. Right, this is how we do it. So the cat sat on the mat and the mat was soft. Now this is the statement. Now how do we calculate the frequency? Pretty much self-explanatory, but let me write calculate frequency. Simple English and mathematics here. So let's divide this into categories. So the first is word and the second is nothing but the frequency. Second is frequency. The first word is the cat. So let me just write it completely. The cat sat on a mat and what was the mat was soft. Okay, so let me just write mat was soft. Okay, now how many times we have the or the? So we have 3 times, right? If you can read it over here, the here also the mat and the mat was soft. How many times we have cat here? So the occurrence of cat is only 1 time. Then sat is again 1 time. Then on is again 1 time. But if you talk about mat, you can see that mat is twice here also and here also. So the mat becomes 2. So mat becomes 2. And was is again 1 and the soft is again 1. Then how to calculate the frequency, guys? So let me just write it here too. I can watch it as well. So the third step is we have to calculate average frequency. So I'm just writing it in acronym now. So calculate average frequency. Let's call it CAF, the acronym, which will help us later on. So CAF. And so how many total words we have? Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 total words. Let's call this total word count. So we have total word count equals 10. Maybe we can call this TWC. We need this acronym, the sort of when we are writing the formula, which will help us reduce the time there. So total distinct word. And how many total distinct word that we have? So we have, let me just count it. 3, 4. We have 7. So total distinct word 7. Let me call this TDW. Now what is the average frequency? A simple mathematics. So average frequency in this case is TWC by TDW, which is nothing but 10 by 7. How much is this? Let me just hit 7. 1.3. Okay, so 10 by 7, 1.3. This is my average frequency. Okay, this looks nice. Now The step is we need the variance of word frequency, okay, before calculating the burstiness. So the burstiness formula, the formula of burstiness is, let me just write it over here, or maybe I'll write it in the maybe I can write it over here. So burstiness, if B is burstiness, the formula is variance by the square of average frequency. So I'm just writing it AF square. This is the formula of burstiness. So variance by square of average frequency. Okay, so now let's calculate the variance here. So variance of word frequency, variance of word frequency. Now the variance, if we write it V, it is summation of frequency minus average frequency, and that's again the square, and then divided by, or let me just write it like this, TWD, which is nothing but the total distinct word. So just let me just write it. Maybe I can write it for 1, and then we can calculate it. So 3 minus 1.43, if you see 3, which is 1.43, for all of it I have to minus it for all this word that you see, frequency minus average frequency square by TWD. So we have 3 over here, right? We have 3, we have 1, we have again 1, and then we have this average frequency as 1.43. So the 3 minus 1.43, this becomes again the square here, okay, and then we do this with frequency, and then we basically calculate. Let me just I will not write it for all the here, but we can just explain here. I have already done this calculation. In last we defined by 7, because you can see this total distinct word, which is 7, and this comes as something like 0.74. Between 0 and 1, the score remains between 0 and 1 here. Okay, so you can see the summation. So even if you're writing it, I can just show you one more time. So 3 minus 1.43 square, and then the next one is, I do have the final value, which is 0.74 for this sentence. Now the 3 minus 1.43, the next become 1 minus 1.43. This goes like this, and then it again goes to the end, which is again 1 minus 1.43. For all of this, minus average frequency and the square of it, and then we are doing the sum and then dividing by total distinct word, which is 0.74. So this is the variance value that we got. Now in last step, we have nothing but the burstiness score. So as we saw, the burstiness score is V by average frequency, so variance by average frequency of square. So this goes like this, 0.74, that we can just see on top, variance of word frequency divided by our average frequency was 1.43. If I just make it square, we get our value as 0.37. Okay, so burstiness score in this case 0.37. Now what does it means? Okay, what do we mean by 0.37? So it suggests that there is a moderate deviation. There is moderate deviation in the text data, because the value lies, as you can see, as we have explained above. Sorry, not for this, and this is just a typo, this is just a mistake. This value is not between 0 and 1. Variance is not between 0 and 1. Burstiness score is between 0 and 1. So this will become between 0 and 1. Okay. So occurrence. So basically this denotes that occurrences of words in the text are relatively evenly distributed around the average frequency. Okay, this is what it means. Okay, so it has moderate deviation in the word. So based on burstiness and perplexity, we are going to write a function, basically a function on GPT-2 model. So all these techniques or formula that you are currently seeing for perplexity and burstiness, it depends on what kind of language model you are taking. So you can see that we have taken a bigram model. It completely depends on what kind of model you are taking, what kind of model you are trying to work with. So if you are working with closed source model, it's very difficult for you to find it out whether there are plagiarism in the content, if you really want to do it with more accuracy and efficiency, because for closed source model you do not know the entire things, what kind of corpus that they have been trained on, what kind of text corpus they are considering, complete the architecture as well. But When you talk about open source model like GPT-2 for example, or BERT for example, or any other current open source model like for example Alpaca, etc., for that they have given all the information and you can go ahead and calculate something like this. Now let's go and write the code to build the application, and you can see I have created a folder called GPTZero. We are naming it GPTZero, and we have opened this in VS Code. You can currently see I am opened this in VS Code. Let me just go back to my VS Code here. So I am on this VS Code. These are the dependencies or libraries that we need. So we need natural language toolkit, NLTK, and we need Streamlit because we are going to create a Streamlit application. We have matplotlib for basically visualization. We have torch, for it's a deep learning library that we need to work with transformers, and GPT-2 model because we are going to use their torch based backend, and the sentence piece which is a dependency of transformers, and plotly for the chart. Let me create a file. You only need to create one file. I'm just going to call this app.py in this case, app.py, and let's create the Streamlit application first. So I'm just calling it import Streamlit here in this case, import Streamlit as st, and you can see I have installed all the libraries here, guys. Import Streamlit as st, and let me just give it a title. What title we can give? So for now let's call this GPT sealed. I'm calling this GPT sealed. This is my title. Now what's going to be my next line here, guys? Let's have a text area. So I'm just going to call it if st dot, okay, not let's have this a variable first. So text area, or maybe text input for example, or let's have text area. So text area, st dot text area, and enter your text for example, and we'll customize this later. Text area, st dot text area, enter your text, and the next becomes if text area is not none, and let's have a button there. So I'm just going to call if st dot button analyze. This is going to be the name of my button. Just write something for now. So if st dot text or st dot write, there is nothing but st dot text, st dot write something, welcome or something. So this is just for example how do we run a Streamlit application. So Streamlit run app.py, and it will open the app in a new tab here, guys. You can see that in my browser I have a text area that, and the app name is nothing but GPTZero. Okay, generative pre-trained transformer. I don't know, we are not talking about building a GPT here, but GPTZero, which basically will help the end user to at least cross-check their content if there are any kind of cues, or if there can any kind of sign that if this content are being generated by AI or not. You can see there is a text area. Now I can write some text into this. Maybe I can go to Wikipedia AI or something, and I'll take their content, and I will try this content as well. If you click on analyze, you can see it says welcome, but this is not what we want. Let's come back on our code here. And anyway, let me just first explain what I'm going to do now. So you can see this is basically in the center of this layout or the page that we are currently seeing. I want to utilize the full width of the layout. Okay, I want to utilize the complete width here. I don't want this container or container fluid. If you are familiar with web terminologies or web technologies, you will understand what I'm talking about. We do not need this container fluid or container. Let's go back to this. Your first line of Streamlit app should start with this. If you are trying to utilize the complete width, st.set page config. So it has a method called page config, which gives you an option to control the width. I'm just going to use layout wide. If I show you now, go back, rerun, and now you see that we have a full width layout here. Okay, and you have an option of enter your text where you can enter your text also. So now let me go back here and let's work now. So let me remove st dot this one, st dot button analyze. We also need columns. Now what do we mean by columns here, guys? Let me just write it. st.columns give 1 1 1 equal distribution. Now if you come back, I want to divide this layout in 3 different columns, okay, and all having equal weightage, okay, and that's what I'm doing here. So st.columns, 3 columns, and all are having the same distribution or weight, okay, 1 1 1. If you want to give more weightage to the middle column or the column 2, you can give it by 2, for example. Here 2, which will have the twice the width of the other 2 columns, but I'm just going to have this. In the first column, I'm just going to write with column 1 st.info status message to show your input text. For example, let me just write this, your input text, and in this I'll just show st.success one another status message given by Streamlit, the method info success warning and error. In st.success, what I'm going to write, the text area that contains our input text. Now let's see that. I'll just do, for example, and let me just write the code for column 2 and column 3 as well. So with column 2, let's have st.info again to maintain the uniformity for all the columns, and here we'll write, for example, calculated score, calculated score, where we'll show our score like Perplexity and Burstiness, and also based on those values we'll also give some insight whether the content are being generated by AI or not. Okay, so with column 3 we are going to again write st.info here, and this basic insights. For example, if you want to give some other insights as well. Now let's head back to the browser, rerun, and I'll just use this artificial intelligence something here. Let's copy till this, come back, paste it over here and analyze. Now I click on analyze, you can see we have this here, guys. Okay, so we have our input text where you can find it out here. This is our input text. Artificial intelligence is intelligence perceiving, synthesizing, whatever that from Wikipedia that we have got. We have the column 2 where we'll write the code for this column, and then we have basic insights. Okay, now let's just come here, okay, and I'll start importing other libraries or dependencies. Okay, the first one is from transformers import GPT-2, which is the open source implementation on Hugging Face. So GPT-2 tokenizer, and then we have GPT-2 language model, so that's called LM head, and the model LM head model. Let me just show you guys what I'm talking about. So if you come on this GPT-2 Hugging Face, you can go through their model cards, everything over here. Okay, you can see they have everything defined over here. If you want to study it in more details, you can also do that. So for now, let's just go back here on this app. Now you can see GPT-2 tokenizer, GPT-2 language model or GPT-2 LM head model. Now we also need torch. Without torch we cannot work, right? So torch, import torch, and then we need natural language toolkit, import NLTK, and couple of dependencies, right, from NLTK.utility. So .util import, we need, for example, let's have ngrams if we need it. Maybe I can explain with some functions as well if required. So utils import ngrams. We can also import from NLTK lm.preprocessing import pad sequences, because we are going to work with pad sequences. So padding sequences, pad sequences. NLTK.lm preprocessing import pad sequences from NLTK.probability import frequency. We can have this for basic details. I will explain that. Frequency distance. So frequency dist NLTK.probability. What else we need? We also need plotly to plot something. So import plotly dot express as px. We are going to use Plotly Express, import Plotly Express. Now we also need from collections. So from collections import counter, because we are going to find out the most repetitive word, for example, maybe for counter. From collections import counter from nltk.corpus. So let's have this corpus. We need stop words to clean our data a bit, import stop words or handle stop words, etc. And then we need string as well, so import string. This is, we are, I think, done with the imports. Now let's load the GPT-2 model, guys. So load GPT-2 models, tokenizer and model. So tokenizer and model. Load GPT-2 tokenizer and model. The first is tokenizer, the variable tokenizer, and GPT-2 tokenizer dot from pre-trained. So we are going to use that from pre-trained, and from pre-trained nothing but GPT-2. And same goes for model, guys. So model, and we are going to use again, yes, the correct. So that I am using tab 9, guys. Okay, the tab 9 code assistance, helps you write code a little faster. So GPT-2 lm head model dot from pre-trained, and here again goes the GPT-2. So we are sorted with the model now. Now let's write the function for calculating the perplexity and burstiness. Okay, so the first is that we are going to write calculate. So the first is calculate, and let me just write it perplexity, calculate perplexity. And in this we need text input, so let me just call it text, and let me just write the function now. So we are working with a transform model, so we have to first encode it. So I'm just going to do we have an input that we need to encode, so encoded input, and then we have this tokenizer dot encode. Tokenizer dot encode, we are doing the pre-processing step here, guys. So tokenizer dot encode, we have the text, and in this text we can have add special tokens. We keep these parameters as false. We do not need any special tokens addition here. So add special tokens, and then we are using PyTorch here, torch here. So our return tensors will be pt. So return tensors, and this return tensors will be pt. This looks nice. Okay, let me just give some space over here. Encoded input is done. Now we need the IDs. So input IDs, and in this input IDs, encoded input, and first one, this looks nice. Now with the gradient, so with torch, how do we write? So with torch dot no grads. So with torch dot no grad, torch dot no grad, and then becomes the outputs. So outputs that let's pass that in model. So we have to pass this input IDs to the model that we have loaded on top. So input IDs, this looks nice. Then again the logits. So output dot logits. Okay, invalid pointer selected, please changing it. Okay, outputs dot logits. This looks nice. Output dot logits. So this is basic GPT-2 code that we have so far written here. Now let me just define a variable called perplexity, and in this perplexity we'll have torch dot, can we get x here, exponential? Okay, x, there should be a method, and in this we can write and then functional cross entropy. So torch provides a cross entropy method, so I'm just going to use that. So torch nn dot cross underscore entropy. You can see it over here in this entropy. Now what we're gonna do, we have this logits dot view. Okay, logits dot view, start from -1, and then logits dot size, if that size again of is to -1. So logits view -1, logits dot size -1. Then we also need to view the input IDs dot view, input id dot view, and this become -1 again. So this looks good. So this is for Perplexity. Now just let's return, we need an item of this. So I'm going to use default Python method. So Perplexity dot item. Okay, now this is what we are returning here, guys. So we are using the cross entropy function of torch.nn. Okay, cross entropy looks good. So we have logits view -1, logit size -1, input IDs view 1. Okay, this looks nice. So let's also write the function for burstiness, which is much easier to interpret at this moment, I will say. So defining calculate burstiness, define calculate burstiness, and here again we have to pass the text as a param. So text and calculate burstiness. So the first thing is, let's have a tokens here, guys. So let me just call it tokens. We need natural language. We can use the first, let's do some pre-processing. So I'm just using nltk.word_tokenize method here, guys. So tokenize, this looks nice. Let's lower the text if we have some uppercase. So lower, this looks nice. So the first line, tokens nltk.word tokenize, word_tokenize, text lower, this looks good. Now the frequency. So for frequency, we will just use the nltk method there. So word, let call _frequency, and then just we're going to use frequency dish. So frequency dish tokens, this is okay. And let's have a repeated count. So repeated count equals, so that will go summation of, we are using count, so count greater than 1 for count in values. So word frequency dot values, yes, word frequency dot values, this looks nice. Repeated count, some count greater 1 for count in word frequency dot values. Okay, now let's write the burstiness score here. So let's define a variable called burstiness score, and this burstiness score we are going to write repeated count and the length of word frequency, and that's what we also saw in the formula there, or the explanation on burstiness and also on the perplexity, right? This was the formula, repeated count by length of the word frequency. And let me just return the burstiness score here. So this is for burstiness score, and on top you have see the return the function for calculating perplexity. But when we are calculating the perplexity, it was more aligned towards which language model we are using, because GPT-2 has been trained on a different text corpus if we use alpaca or any other recent large language model. So you have to be very attentive there, you know, if you want to work. But it should work for most of the cases, guys, because we'll take some example from ChatGPT and you will test this tool out, okay, that what kind of result we are getting. But I hope you understand that calculating perplexity is not that straightforward. It completely depends on what kind of language model that you are using. Okay, Burstiness is like, you know, you can control with natural language toolkit as well. Okay, so now let me just write one more function. Let me just plug this charge in. So now we're going to write the function for example, or let's just do one thing. Let me just remove the charger quickly. Okay, yeah, so let me just write the column 2 code where we are going to calculate the score, calculating the score. So if you see, we are going to here use that perplexity and burstiness. So let me just define a variable. So perplexity here again, and in this we are just going to use that calculate perplexity function. So for calculate perplexity, here we'll pass our nothing but the text area variable which contains our input text. On perplexity we have written calculate perplexity. Let's write the burstiness score. So burstiness score, we are writing calculate burstiness function that we are going to use text area. This looks nice. Now let me just write it. So st.write, for example, st.write, or what should we write, or should we go ahead, let's go ahead with the success message there. Okay, so st.success, your, for example, or let me just write Perplexity score, and then let me just write here Perplexity. Yeah, this looks nice. Same goes for Burstiness as well. Burstiness score, this is okay. st.success. Now let's write a if else logic there, guys. Okay, pretty much simple. So if, and this is what I also need, maybe for example the help, right? I need help on this part from you as well. If you have earlier worked with perplexity, burstiness, randomness, coherence, all these related or terminologies have been used interchangeably, right? If you have worked in these areas, let me know what is the right threshold values. Okay, how should we choose a threshold values there? For example, if I say, okay, if perplexity greater than 30,000, because I have used this kind of tools, so from my expertise or experience, I might say if perplexity greater than 30,000 and burstiness score is less than 0.2, for example, I'm just writing, okay, so give me a error message there. I'm just going to use this error method, that text analysis, for example, let's write text analysis result, and in this text analysis result I'm just going to use, for example, this or maybe not like this. So text analysis result, let's write AI generated content, something like this, AI generated content. This is a threshold value that I have selected, okay, or I have chosen. But if you think that okay, there can be improvement, okay, in this, please let me know your thoughts in the comment box, or you can also reach out to me through mail or through my social media channel as well. So on else, let me just write a success message. If it says okay, the content is not being generated by an AI, so text analysis result in this case says likely not generated by, something like this, okay, likely not generated by AI. Okay, here something like this, or I'll rather prefer a large language. For example, let's go AI here. Okay, so st.success. So this looks nice. Okay, and so what we have done so far, guys, so far we have imported all the libraries. We loaded GPT-2 tokenizer and model from Hugging Face, and then we have written couple of functions for calculating the perplexity and calculating burstiness on top of your text. And then we have a simple Streamlit application over here, which kind of have three columns, and we have divided in the equal distribution. In column 1, pretty much self-explanatory, just printing the text area, the same text. And then in column 2, we are using both the functions, calculate perplexity and calculate burstiness, and we are having a business logic kind of a logic there, right, where we're trying to have a threshold values. And with column 3, we can use column 3. So what I'm going to do in column 3 is, let's write one more function to give some kind of basic information, what kind of repetitive word that we are using. And for that, we are going to use plotly express. So I'm just going to write define plot, for example, plot top repetitive word, or repeated word. Okay, so repeated word, and I'm just going to use, again, the text will be there. I'll give some space here, by the way. So text here, and the first thing is again tokens. So let me just write tokens equals, we are going to use, let me just split it first. So text split, this looks nice with the method here. So text split, basic Python method, text.split, and again the stop words, stop underscore words, for example, and this goes to set, and we are going to, let's use the English stop words dot words, and this words is nothing but we are having only English as a language for this video, guys. So English, and pretty much self-explanatory. Now tokens, in these tokens we are going to lower it first, so let's do that in a list. So token, and store that in a list, token dot lower for token in tokens, and also if tokens in tokens, if token dot lower if token dot lower already not in stop underscore words and token dot lower not in string that we have, so string dot punctuation I hope I spelled it correctly, string dot punctuation. Okay, so here basically we are doing the text pre-processing, guys. So token dot lower for token in tokens, if token dot lower not in stop words, and token dot lower not in string dot punctuation. Looks nice. Let's count this now. So I'm just writing some lines here. So we're counting it. How do we count it here, guys? So let me just do word count. So word counts, a variable in this word counts will have word counts, word counts. Okay, so word counts dot most common. Okay, so word counts, but we have to first count the word. So how can we count the word is through counter. Okay, so we have counter imported, so counter, and we just have to count nothing but the tokens. So let's just count the tokens. Okay, word counts equal counter tokens. Now top words are nothing but word count variable, word counts, and the most common, so most underscore common, and in this most common we just need to use 10. We just need the 10 most common word. Okay, most common. Okay, now this is done. So now extract the word and let's count that as well. So let's call this words equal word for word and count in top words. Okay, count in top words, and same goes for count. So counts equal count for, no, this is not right. So count for word and count in top words. This will be top words, count in top words. This looks good. Count and count for word, count in top words. Now what next? Okay, now we'll have, let's plot it. So let me just write the couple of lines here for plot. So how do you want to plot is, so let's call it a fig variable. In this px dot bar we'll have a bar chart in plotly express. So px dot bar, my x is nothing but the words and my y is nothing but the counts. And then let's have some labels. So labels should be a dictionary. So labels, and in this labels the first is x. You can just write it, for example, caps words, and y is going to be the counts. Perfect. Can we have a title as well? Title, and in this title just writing top 10 most repeated, something like this. Okay, repeated words, top 10 most repeated word. This is the figure. Now st.plotly underscore chart, st.plotly underscore chart. Then we have fig, and in this fig let's also, so streamlit.plotly underscore chart, this provides you a method to basically plot your plotly chart. And I'm going to use the container width as true. I want to use the entire column width there, by the way. So use container underscore width, and this is a boolean value, so this is going to be a true here. So use container width true. I think we are sorted with our function, guys. Okay, we have the functions, we have this Streamlit app. Let me just call it also GPT seal, for example, and let's call this AI Plagiarism GIA, alright, Plagiarism tool or something, or app. Let's call it detector, because an app and tool requires a lot of other things as well. Okay, it's an integration of multiple components, when that's how it becomes an application or a tool also. And I think we are sorted with this. Now let's move back to the column 3 here, guys. So in column 3 what we're going to do here, st.info, let's use this function. So plot top repeated word, and we're going to use the text area. So text area here, And I also want to use a disclaimer, guys. Okay, I want to also send a message through this video that this kind of systems, AI plagiarism detector or the system GPTZero or Turnitin, for example, it should not be taken as your final decision maker tool. Okay, and this is also for academia, the professors, or whoever the audience who is watching this. If some of you are watching, these tools, if you take chatgpt for example, chatgpt does not write Oxford English, it does not write Shakespeare like English, right? Those kind of words or terminology, it's a write very simple English. Okay, of course there are some possibilities that sometimes people use this for plagiarism, but these tools are hardly of any worth in my views. Okay, academia should not rely on this tool to at least flag their students assignment or the research paper, for example. When I talk about the research journals, houses or media houses, for example, any kind of content, this can be as a supplement in your work of your auditing work or whatever work you are doing. Please do not fully rely on these tools. They are not that accurate. They will never be that accurate. Okay, they cannot become a tool which can find out the AI plagiarism with efficiency and accuracy. That can never happen. Okay, at least I can say that with my experience. But anyway, let's move on. So I also want to write something here, so I'm just going to call it st.warning. So in st.warning, and disclaimer, and here let's have a disclaimer. So what we can write, so AI something like, or let's take a, maybe we can, or let me just write it. So AI plagiarism detector apps can assist in identifying potential instances of plagiarism. Or let me just write something. Okay, so however, let me just do Alt G here. So however it is something, a short message, it is important to note that their result, for example, that their results are not fully accurate or fully accurate for now. Okay, please use this information with responsibility and don't make the decision based on this tool completely. Okay, now suppose this is a warning message that I also as a disclaimer want to give. Okay, so we have written our code. Now let's do one thing. Let's go back to the browser here, guys. We'll see, and we'll now run this application again that we have. It will take little time at the first time because I think we have to run this. So let's go back and let's see. Okay, let's run this now. You can see I got an error. It says cannot import name pad sequences from nltk.lm pre-processing. I think let me just remove that. I think we do not need that as well. We are not working with pad sequences for now. So I'm just going to remove this. Let me just go back again, rerun. So it downloads the model, guys. Okay, so what it will do, it will download the models from PyTorch, Hugging Face, like GPT-2 model. So let me do one thing. Let me pause the video. I'll come back once I get the response for this one, basically, or the model gets loaded completely. So you can see, guys, that we have got our response. Okay, and it looks beautiful so far. Okay, if you see, we have our input text. So the model has been loaded, and we got our response as well for this Wikipedia that we searched. Okay, and what we did, we just copied it from here and we pasted, and you can see that in the left hand side we have your input text where we are saying the same text, and we have our detection score, guys, the Perplexity and Burstiness score. Based on that score that we also have written in our code as well, the logic, we are getting this text analysis result. And we also have a disclaimer. I want to put the disclaimer in the place which says use this tool responsibility. This should not be act as a decision maker. This can help you, it can act as a supplement, of course, but please rely on the manual verification for this accuracy and all those things. Then we have basic details in the right hand side, where we have now plotted this with the help of Plotly Express. We are deriving top 10 most repeated words. Okay, you can see AI, artificial intelligence, include speech, systems, human, etc. have been done here. That can be improved further as well. Now let me do one thing. Let me just remove this from here, and I'll also, so this is an article from McKinsey. You can see it says mckinsey.com. This is an article. Let me take this paragraph for example. You can also test it out with other articles as well. So I am testing McKinsey and Wikipedia, because I feel that this can be used to test this tool out, because I believe that these are not being generated by AI, at least the current one that I'm seeing. So this article has been published last year. Okay, so I do believe that this has been written by a human only, not been generated by an AI. And this Wikipedia that has been on wiki as well. So that's why I'm testing with this tool. Okay, so if I click on this, analyze, what it does, it calculates the score for you, and it will gives you text analysis result, like likely not generated by an AI. So we have our input text that we have uploaded or put here over in this text area. We have our detection score. We are getting that this is likely not generated by AI. Then we have this basic details, guys, top 10 most repeated word that we are getting it over here. So this, you can see that we have tested with McKinsey and this Wikipedia. Now let's go to chatgpt and let's ask some question. For example, write a short story on some topic, like for example circular economy. Okay, one of the example, under 200 words or something. Okay, so this is my query to chatgpt, and you can see it's writing something. Okay, it's writing couple of paragraphs there. We'll take this and we'll see what kind of response by the way we are getting on this. Okay, so let me just copy this from here. Okay, you can see I'm copying it from chatgpt, and I just paste it over here. Click on analyze. Let's see if we are getting any kind of a hint or cues that it is being generated by an AI system. And you can rightly see we have got it like text analysis result, and you can see the Perplexity score has gone high, and I'm very happy as the way with a very decent effort we have come up with something. You can see in this text analysis result, and this is happening live, guys. We have used response from ChatGPT again, which is based on DaVinci 2 or DaVinci 3 currently on the free version. ChatGPT is using GPT-3 models for now. I have the access of GPT-3, and you can see that the response, the LLM response that we have got from our tool, you can see it says text analysis result AI generated content. Okay, it's fantastic, right? So we have this left hand side, your input text, we have detection score, we have basic details. Let's ask one more question. For example, can you write an abstract? Can you write an abstract on circular economy? So if we're writing some paper, for example, on circular economy, and we have abstract, sometimes we are generating this abstract from maybe large language models where we don't know that, right? So can you write an abstract on circular economy, under 2 paragraphs or something? Okay, let me just see that. So you can see it's giving you some response. We'll try with this response as well. Okay, a very generic question, a very generic response. You can change the question. Let me know what kind of feedback that you get from this tool. So you'll have some feedback that you can give it to me. Okay, or use this tool at least to improve further. If you can add more techniques here to try to come up with something like GPTZero, you can see it over here, or Turnitin, for example, and these are paid. We can create a free here, guys, isn't it? We can also do that. So if you see, I'm clicked on analyze, it tries to run the model again. You can see, let me just go back here. You can see it's likely not generated by AI this time, which makes sense, right? As we say that it might not be 100% accurate. So the first one that you could see that it basically detected as AI generated when we use ChatGPT, and we have tried McKinsey and basically this AI Wikipedia as well. So I think that's it, guys. Okay, that's basically a wrap for this video. I'll say our exploration into the development of an AI plagiarism detection tool. Our app using Perplexity and Burstiness metrics. Please remember that these metrics can provide valuable hints. Okay, and insights into basically potential plagiarism, but it is essential to exercise critical thinking and consider other factors when evaluating the authenticity and originality of content. So please use this kind of techniques or application. If you are using this from GitHub repository or you are using any other tool as well, please use this with responsibility. And that's all for today's videos, guys. If you like the video, if you like the content, please gives a thumbs up. And if you have any feedback, thoughts, comment, if you want to extend this further, if you can contribute together, I will be more than happy to work on to extend this further. Please reach out to me for any thoughts or feedback. That's all for today's video, guys. See you in the next one.